defined as the act or process of changing position or place. We've all experienced motion at one time or another in our lives, whether it be at school, at work, or even at play. But what is the relationship between force and motion? What are Newton's laws of motion, and how can they help us to better understand motion in general? You will get the answers to all these questions, but first let's address some common misconceptions that children have about motion. The first is that objects are kept moving by internal forces, when really they are kept moving with the aid of external forces. This picture illustrates that a man is needed to move the box to the other side of the room. The box cannot move itself. The second is that constant force is required to keep an object moving. If a book is sliding on a table, it does not come to a complete stop because of a lack of force. Actually, it is quite the opposite. The presence of friction, a common force, slows the book down, eventually bringing it to rest. The final and biggest misconception is that heavier objects fall faster than lighter objects. On the contrary, these objects fall at the same rate. This is due to the fact that all objects, regardless of their mass, experience the same acceleration in a state of free fall. There are three types of motion. The first is translational motion, which results in a change of location. An example is a person walking from point A to point B. The second type of motion is called oscillatory motion. This type occurs when an object fluctuates between two locations, like in a pendulum. Rotational motion occurs when an object spins. Earth's rotation is a great example of this type of motion. Newton's first law of motion states that an object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and direction unless acted upon by an unbalanced force. The law is also known as the law of inertia. For example, when someone is driving a car and they hit a brick wall, the person driving will keep moving at the same speed that they were moving even when the car stops moving. That's why we wear seatbelts. Newton's second law of motion states that acceleration is produced when a force acts on the mass. The greater the mass, the greater the amount of force needed. In other words, F equals ma. Notice that moving the big rock in the picture is almost impossible due to the amount of force being exerted. Newton's third law of motion states that every action there is an equal and opposite reaction. For example, rocket ships can only take off because there is a force pushing them upwards into the sky. The force pushing downward and the thrust pushing upward are equal and opposite reactions. Without motion, not only would life be boring, but it would be, well, motionless. Remember, at work, at school, and even at play, let motion lead the way.